The first part of the experiment is a laser. And now I'm going to shine the laser onto the second part of the experiment, that's the screen. Now the third part of the experiment is simply a thin piece of wire. Now, this wire is about 100 microns in diameter. So I'm going to slide the wire across, and you need to be quite careful to get it, there we go. You should just be able to see here where the laser is shining over the wire. And on the screen, oh wow! If you look at the spot, you should be able to see that there's no dark line down it at all. It's still perfectly bright. But on either side of it, you can see bright and dark bands extending out many times the diameter of the wire or the laser beam. Well, light waves travel from the laser over to the wire, and they diffract around each side of the wire. That is, they're bent to fill the space beyond and behind the wire, extending over to the screen. So in this region, we observe interference between the light waves that have come around one side of the wire and around the other. Where the waves are in phase, that is, where the crest of one wave matches the crest of a wave that's come around the other side of the wire, we observe constructive interference. And that's what leads to these bright regions on the screen. And it's what explains the absence of a shadow in the center. In this region, we've got constructive interference from light which has traveled around each side of the wire, because this point is exactly equidistant from either side of the wire. We also observe destructive interference. That's where the light traveling around one side of the wire interferes destructively with the light that's traveled around the other side of the wire. And that's what leads to the pattern we see on the screen.